All right, so if you've ever tried to build any kind of software, you know the real hard part isn't the coding itself. Nope, it's the decisions you make before you even start. It's all about architecture, how you lay out your classes. You get that right? Smooth sailing. But if you get it wrong, oh boy, you are in for a world of pain. So today, we're going to tackle one of the biggest design dilemmas in Python.
You know, I really love this quote. It just gets right to the heart of it. Object-oriented programming, or OOP, it isn't just a bunch of syntax rules. It's a whole mental model for how you look at a problem and break it down into code. It's about thinking. And today, we're going to explore two really powerful ways to think about how all the pieces of our code should fit together.
Okay, let's just quickly nail down the absolute basics. Think of a class as a blueprint for a house, right? The blueprint lays out the whole structure, how many rooms, where the windows go, but you can't live in the blueprint itself. An object, then, is the actual physical house that you build from that blueprint. And just like in real life, you can build a whole neighborhood of different houses, tons of objects, from that one single blueprint. Now, here's where it starts to get really interesting. Your project starts out simple, but then, of course, the requirements get bigger. All of a sudden, you don't just need a blueprint for a house, you need one for a mansion, a bungalow, a townhouse. They all share common things, like walls and a roof, but they've all got their own unique features. So how do you handle all this without just copying and pasting code all over the place? Because that is a trap we definitely want to avoid. Well, the answer comes down to two big design philosophies, two totally different ways of thinking about how our blueprints should relate to each other. You can pretty much think of them as two competing architectural styles for your code. On one side, you've got inheritance. This models what we call an is-a relationship. The best analogy here is a family tree, where traits get passed down from one generation to the next. Then, on the other side, you've got composition. This models a has-a relationship, which is much more like building something complex out of a bunch of versatile Lego blocks. So, let's actually break down what that all means. All right, let's dive into that first approach, inheritance, the is-a relationship. Just keep that family tree model in your head as we go. It's all about creating specialized versions of a base blueprint. So with inheritance, a new class literally is a more specific version of an existing one. Let's imagine we're building an HR system. A salary employee, well, that is an employee, right? It inherits all the basic employee stuff, and then it just adds its own special details, like a fixed salary. You could even take it a step further. A commission employee is a salary employee. On the surface, this sounds perfect. You're reusing code, everything's in this nice, clear hierarchy. But, and this is a big but, there's a hidden danger. Because if you lean too heavily on this family tree idea, you can walk right into a nasty little trap. It's called the class explosion problem. And this quote just nails it. Imagine your boss comes over and says, "Hey, we need a temporary, part-time commissioned manager." With a rigid inheritance setup, you might actually have to create a brand new class just for that one weird combination. And as more roles and pay types get thrown into the mix, your beautiful family tree just explodes into this tangled, unmanageable mess of code. It gets ugly fast. So, what's the alternative to that mess? Well, let's check out our Lego block approach, composition. This is where we build our complex objects not by inheriting from a parent, but by containing other smaller objects. See, instead of saying an employee is a certain type, we say an employee has certain components. We can have one super flexible employee class that we build up from these independent parts. An employee has an address object, it has a role object that defines its duties, and crucially, it has a payroll policy object that decides how it gets paid. You just plug and play the different Lego blocks you need for any situation. Now, this whole Lego block approach gives us an incredible superpower. We get the ability to change an object's behavior while the program is actually running. This is something that's really hard to do with a rigid inheritance structure. Let's look at a really practical example. Say you've got a manager who's on a fixed salary, but they need to switch over to being paid hourly. With composition, it is this simple. You just grab the manager object, you create a new hourly policy Lego block, and then you just swap it into their payroll spot. That's it. The person is still an employee, their identity hasn't changed, but their payroll behavior has been completely transformed, right on the fly. So we have our two big architectural styles, right? Inheritance and composition. But to really become masters of our blueprints, we need a couple of specialized tools. And these are tools that work on the blueprint, the class itself, not on any one specific house. This is where we need to talk about class methods versus static methods. Just think about it for a second. Sometimes you need a function that's related to a class in general, but it's not tied to any one specific object you've made. For instance, maybe a little utility to check if a certain age counts as an adult, or a special method to create a person object from their birth year instead of having to calculate their age first. These are actions that belong to the person blueprint as a whole, not to any single person. Okay, so here's the crucial difference, and it's actually super simple. It all comes down to that very first parameter. A class method, decorated with @classMethod, it always gets the class itself passed in as the first argument, which we usually just call CLS. And that's its superpower, because it means the method can actually interact with the class. A static method, on the other hand, gets nothing. It's basically just a regular function that happens to be living inside the class, mostly to keep things organized. It has no idea about the class or any objects made from it.
And this leads to their classic use cases. We use a class method as a kind of factory. It's an alternative way to build an object. So this from birth year method can take a year, do the math to figure out the age, and then use the class, CLS, to construct the person object correctly. But we use a static method for simple utility functions. IsAdult just takes a number and returns true or false. It doesn't need to know a single thing about the person class to do its job, so we make it static.
Whew. Okay, we've talked about the IsAFamilyTree and the HasA Lego set. We've looked at tools that work on the blueprint and tools that work on the building. So let's bring it all home. How do you actually choose the right design for your project?
This really is the million-dollar question every developer has to ask themselves. And the answer, like always, is, well, it depends. But there are some really clear guidelines that can help you make the right call.
This right here, this is your cheat sheet. You should use inheritance when you have a genuine, true is-a relationship. A poodle is a dog, and you're pretty sure that family tree is going to stay simple and stable. But you should use composition when you have a has-a relationship. A car has an engine. Composition is your best friend when you need flexibility, when you want to be able to change behaviors on the fly, and especially when you want to avoid that awful class explosion we talked about. Honestly, the general advice these days is, when in doubt, favor composition over inheritance. It just keeps your options open. So the next time you sit down to plan out a new feature, just ask yourself this one simple question. Am I building a rigid family tree, or am I building a versatile set of Lego blocks? The answer you come up with won't just shape your software, it's going to shape the way you think in code.